This is a website that I created which works just like,
Google.
but do not create one.
No. That's why I clicked this video, bro.
Don't worry, let's get started. First thing we need is the web pages themselves. But how? Manually entering all the 1.1 billion websites is going to take at least 34 years. Even if you're able to, there are a lot of websites that are getting added to the internet every single second. That's why we need the help of the web crawlers. What he does is simple. I'll ask him to explore these popular web pages. He will then try to find any links from the web pages and add them to a database. Since the internet is very closely connected, we should be able to get almost all of the web pages. So that is our objective. Let's instruct him what to do. First, let's create a function that will extract all the URLs from a particular page. We will do this by reading the content of the web page and finding the anchor tags. Let's take Wikipedia and see how many links we can find.
Wait, it's all Wikipedia?
It always has been.
It's okay, but why do you have incomplete and section links?
Let's ignore the section links as they are of no use. The incomplete links are nothing but the links within the same domain. Let's extract the domain name and add it to them. Let's run it again.
Good job. It fixed it.
Now let's write the code for the crawler. I want him to work like this. I will give him a set of seedlings and a recursive limit. The limit is basically how deep we are going to search for. If you can imagine the whole process as a tree, then the limit is basically the height of the tree. This is to make sure that the crawler stops at some point and doesn't end up crawling the whole web, which might take a very long time. First, let's create the database. Now, let's look at the algorithm. We will run the crawler till we have some URLs to explore. In each iteration, we will have to explore all the URLs in the current list before increasing the height. It is because all the URLs in the current list have the same height. We are also extracting the content, the title, and saving it along with the URL in the database. Finally, let's commit the changes. That's it. Let's try it out. I'm setting the limit as 3 and for the link I'm giving it a blog page. Let's run the file and see the results.
A few moments later.
Next, we need to index the web pages and implement a ranking system so that we can display the most relevant web page at the top. An index is basically we will give a word and it will return the list of URLs that contain that word and their count. Let's create a function to normalize the content. We don't need punctuations or stop words. Let's remove them. We'll also do this process called stemming. What this does is it will convert a word to its root word. For example, let's take the word waiting. After stemming, it will become just wait. Now let's read the database and index them. Next is to rank the web pages. Here I chose to use the BM25 algorithm, which uses the content to rank the web pages. Once we provide a set of keywords, the BM25 assigns a score to each of the web pages and returns them. The higher the score, the better. To compute the BM25 score, we need the average length of the content and a parameter called IDF. This is a formula to find IDF. Here, the capital N is the total number of documents and the small n is the total number of documents that contains the keyword. After this, we are ready to implement the score function. We need additional 2 parameters, k and b, which are free variables. That's it. Let's move on to the main search function. We will now compute the scores and sort them in descending order. We will also implement the update function, which adds a score for each keyword found in a particular website. Now, let's set up a simple Flask server and a simple frontend to check our results.
Thanks for watching. If you like this video, give it a thumbs up and subscribe for more content.